Welcome back to What If, the show that pries open the lid on reality and peeks at what might have been. I'm your host, David, and joining me is the man who does the prying, theoretical physicist Dr. Matt Adam.
Hello, David. Always a pleasure to be here, applying mathematical models to scenarios that would give most people nightmares.
And today's scenario is definitely in that category. It's a question that feels simple on the surface, but the implications are staggering. Matt, take us there. What if planet Earth had formed with double its current gravity?
Right. 2G. It's a beautifully simple premise with catastrophically complex results. The first thing to understand is that gravity is not just a force that keeps us on the ground. It is the master sculptor of our entire world. If you change the strength of the sculptor's hands, you get a completely different statue.
A different statue entirely. So let's start with the clay itself, the planet. How is a 2G Earth different from our Earth on a geological level?
Well, from the moment of its accretion, the planet would be under immense pressure. All that mass pulling on itself twice as hard would lead to a much denser object. Even with the same amount of matter, the planet's radius would be smaller. This compression would superheat the core, making it far hotter and more geologically active for much longer.
So a smaller, denser, angrier planet.
Precisely. Think of a permanent planetary fever. You'd have a stronger magnetic field, perhaps, due to a more vigorously churning liquid core. But the surface would be a nightmare, constant volcanism. Thin, brittle crust that's always fracturing. Mountains couldn't grow tall. Gravity would slump them down, creating vast, thick plateaus instead of jagged peaks like the Himalayas.
So the topography of the entire world would be flatter, more compressed.
Exactly. And above that surface, you have the atmosphere. Stronger gravity means the planet can hold on to gases much more tightly. The atmosphere would be incredibly thick and dense. The pressure at sea level could be 4 or 5 times what we're used to. It would be like living at the bottom of a very deep ocean of air.
And would that air even be breathable?
Potentially toxic. Gases we consider trace elements, like argon or even carbon dioxide, would be trapped in much higher concentrations. Nitrogen narcosis, something deep-sea divers fear, could be a problem just walking around. And the weather? The energy required to move that thick, soupy air would mean that storms would be less frequent, but when they occurred, they would be unimaginably powerful, slow-moving cataclysms.
Okay, this place sounds awful, but life finds a way. How does evolution even get started in a world that's actively trying to crush you?
With great difficulty. From the first cell, the primary evolutionary pressure is gravity. Forget predators. Your first enemy is your own body weight, so life would be robust. Think stronger cell walls, more efficient energy systems. When we move to multicellular life, things get interesting due to something called the square-cube law.
Right, explain that for us.
Simply put, as an object gets bigger, its volume, and therefore its mass, increases as a cube of its length, while its cross-sectional area, its strength, only increases as a square. On a 2G world, this problem is magnified. If you double the size of an animal, it becomes 8 times heavier, but its legs only get 4 times stronger. That's a recipe for collapse.
That's a critical point. Could you give us a more concrete example? How would an elephant from our world fare in that scenario?
An excellent question. An African bush elephant on Earth weighs about 6,000 kilograms. On a 2G world, its effective weight would be 12,000 kilograms. Its leg bones are already near the limit of what they can support. Doubling the load would almost certainly cause fractures. It wouldn't be able to stand, let alone walk. It would be a tragedy of physics. This demonstrates the absolute tyranny of the square-cube law. Large size becomes a severe penalty, not an advantage.
Masterpiece of brutally efficient engineering. It's a stark image. It makes me wonder, would any kind of life actually have an advantage? We've talked about constraints, but is there any area where life would flourish in a way ours can't?
That's an excellent point. Evolution wouldn't be less creative, but it would be creative within a much narrower set of rules. For instance, plant life. Forget towering redwoods. A tree trying to pull water hundreds of feet into the air against twice the gravity is a physical impossibility. So you get a world of low-to-the-ground dense shrubs with immense root systems. Similarly, for animals, you wouldn't have the vast range of body shapes we see on Earth. Instead of branching out, evolution would converge on the most stable body plan, low, wide, and multi-limbed. The ecological niches that on Earth are filled by tall browsers or swift runners might simply be empty. Life would be a masterpiece of engineering, but all built to the same brutally efficient blueprint.
And the animals that live in this thicket,
They would be absolute units. Every land animal would be a fortress of bone and muscle. Skeletons would be incredibly dense and thick. A fall of just a few feet would be catastrophic. To maintain stability, you'd see a prevalence of creatures with more limbs. 6 or 8 legs gives you a lower center of gravity and a much more stable platform. Think of a rhinoceros, but lower to the ground, wider, and with 6 legs, and that's your average herbivore.
beyond just bones, what about internal systems? Does the law affect things like blood circulation?
Absolutely. The heart is a pump that has to work against gravity. A giraffe's heart is already a 2-foot-long, 25-pound marvel of evolution just to get blood up that long neck at 1G. At 2G, the pressure required would be immense. The heart would have to be disproportionately large and powerful, and blood vessels would need to be incredibly reinforced to prevent them from bursting. Even then, fainting or strokes would be a constant risk for any creature with a significant vertical height.
Wow, and what about predators? How would that look like?
Likely mostly ambush predators. Chasing prey would be too metabolically expensive. They'd have to be incredibly powerful, able to generate short bursts of immense force, and flight seems almost impossible.
That's a terrifying image on land. But what about the oceans? We always think of the oceans as a place where gravity is less of a concern. Would that still be true?
To an extent, yes. The buoyancy of water would counteract the increased gravity, making it a more hospitable environment for life to begin and flourish. Marine creatures could grow much larger than their land-based counterparts, just as they do on our world. However, the immense pressure of a denser atmosphere would also mean immense pressure in the waters. The sea level pressure would be much higher.
I was going to ask, could anything even get off the ground?
It's a fascinating problem. The pull is twice as strong, but the air is much thicker, providing more lift. The trade-off suggests you wouldn't get large soaring birds. You'd get small, hyper-efficient flyers. Creatures with enormous, powerful wing muscles and lightweight bodies, beating their wings at an incredible frequency, more like biological drones than birds.
And what about their senses? In that thick, soupy atmosphere you described, would sight even be that useful?
An excellent point. Visibility would be poor. Light would scatter. Things would be hazy, dim. Perhaps hearing or smell would become the dominant sense. Or maybe something more exotic, like echolocation, would be common among land animals, not just bats and dolphins.
Okay, let's make the biggest leap. Intelligent life. If a species achieved sentience on this world, what would they be like? You've painted a picture of squat, six-legged tanks.
And that's probably what they'd be. Bipedalism is an evolutionary nightmare in 2G. So our sentient species is likely short, broad, and multi-limbed. Their bodies are built for power and endurance, not grace. Their psychology would be profoundly affected by their environment. The vertical world, the concept of up, would be a place of peril. Their whole culture would be grounded, literally.
So their architecture, their cities, they wouldn't build skyscrapers.
Absolutely not. The amount of material and energy to build a tall structure would be astronomical. It would collapse under its own weight. Their grandest works of architecture would be horizontal or subterranean, sprawling, low-lying city complexes or vast carved-out underground networks. Their grandest temples would be caverns, not cathedrals.
That makes sense. It paints a picture of a very practical, grounded society. How deep would this go? Would it affect something as fundamental as their language or their philosophy?
Profoundly. In our languages, so many positive concepts are tied to height. We rise to the occasion, have high aspirations, and look up to higher powers. For a 2G species, height is danger. Falling is the ultimate threat. Their language would reflect this. Positive concepts would be associated with stability, depth, and being grounded. Deeply rooted would be a high compliment.
That's fascinating about language. What about their social structures? Would a world where falling is so deadly lead to a more cautious or perhaps a more communal society?
Yes, the great trap. The escape velocity of a planet is proportional to the square root of its gravity and radius. For our 2G Earth, the speed needed to break free of its pull would be about 1.4 times higher, around 15.8 kilometers per second. I would hypothesize a strong lean towards collectivism. On a world where a simple fall can be a death sentence, mutual support isn't just a virtue, it's a survival strategy. Individuals would be less likely to take risks. Society might develop intricate systems of physical support like harnesses or designated spotters for any task involving even minor elevation changes. Innovation would be slow, cautious, and rigorously tested before being adopted.
Which sounds like not that much more, but I suspect it is. So, a society built entirely on caution and mutual support. It sounds stable, but also stagnant. Would there be any room for individualism, for rebellion, or groundbreaking art? Or would the sheer weight of their world crush that spirit?
That's the core philosophical dilemma they would face. A rebel, an individualist, isn't just a social outcast, they're a direct threat to the safety of the group. A person who builds something a little too high or takes a shortcut across an unsupported ledge endangers everyone. Their art would likely be masterful in its precision and craft, but perhaps lacking in wild, abstract leaps. It would celebrate the community, the structure, the strength of the whole, rather than the singular vision of one person. True genius would be expressed in making things safer, stronger, more efficient, not necessarily different.
This idea of a collectivist and cautious society is fascinating. What about their philosophy or even religion? On Earth, so many of our mythologies are filled with winged deities and heavens in the sky. That seems unlikely there.
That's a profound question. Their deities wouldn't be sky gods, but earth gods. Divinity would be found in the deep places of the world, in the stability of the rock, the heat of the geothermal vents, the crushing pressure of the deep oceans. Their concept of a hell, if they had one, might be a place of weightlessness, a terrifying, untethered void. Their entire spiritual framework would be inverted from ours. Enlightenment would be found by digging deeper, not by ascending.
Let's delve deeper into their technology. You've mentioned the immense challenge of space travel. What about everyday technologies? How would something as simple as transportation be different?
Transportation would be a monumental challenge. The wheel, one of humanity's most fundamental inventions, would be far less effective. The friction on the axle would be doubled, and the energy needed to overcome inertia would be massive. Any vehicle would have to be incredibly robust and powerful. I imagine they would prioritize rail systems with ultra-hard, low-friction materials, perhaps magnetically levitated trains if their technology progressed that far. But personal vehicles like cars would be inefficient luxuries.
So they would be a civilization forever trapped at the bottom of their gravity well.
It's a colossal difference. Because of the tyranny of the rocket equation, every bit of extra velocity requires an exponential increase in fuel. A rocket that could get to orbit on our Earth would barely twitch on a 2G world. They would need technologies far beyond our own just to get a satellite up. Manned spaceflight might simply be impossible. Imagine their astronomers, brilliant minds charting the galaxies, understanding the cosmos, but knowing with mathematical certainty that they can never, ever visit it. Their sky is a museum they can't enter. It would fundamentally shape their philosophy, perhaps making them more introspective, more focused on their own world because it's the only one they'll ever have.
That is a haunting, lonely image. And what about energy? All this moving around, all this building, it would require astronomical amounts of power. Would they have the resources for that?
Energy would be their primary societal driver and limitation.
The heightened geological activity might provide abundant geothermal energy, but fossil fuels would be buried much deeper and far more difficult to extract. Wind power would be less viable due to the thicker, slower-moving air. Any energy source would be precious, and their technological development would be a direct reflection of their ability to harness it efficiently against the relentless pull of gravity.
It seems like every technological step we take for granted would be a Herculean effort for them. What about something less tangible, like communication? Would that thick atmosphere affect radio waves or other forms of long-distance messaging? Or what if we took one of us, an ordinary human, and just put them on this 2G world? What's the experience like?
It would dramatically. The dense and likely turbulent atmosphere could cause significant interference and signal degradation for high-frequency radio waves. They might have to rely more on lower-frequency transmissions, which can travel further but carry less data. Or they might leapfrog that technology entirely and invest heavily in physical, ground-based networks like fiber optic cables, which would be shielded from atmospheric interference. This reinforces the theme. Their technology would be robust, grounded, and interconnected, rather than ethereal and wireless like ours is becoming. And for an ordinary human, well, the experience is short, and it is fatal. Immediately, your body weight doubles. Your legs, not designed for that load, would likely fracture. Your heart, which fights gravity every second to pump blood up to your brain, would fail. It simply doesn't have the power. You would suffer a cerebral hypoxia and lose consciousness in seconds.
So you just collapse.
You collapse internally and externally. Your spine would compress. Your organs would be put under massive strain. Every biological system we have is calibrated perfectly to 1G. It's the invisible constant that has governed our entire evolution. Change it, and we simply fall apart.
It's a powerful reminder of how fragile we are, and how much we are a product of this specific world.
Absolutely. We are children of this particular gravity. It's in our bones, our blood, our every breath. To imagine life on a 2G world isn't just to imagine different animals. It's to imagine a completely different answer to the question, what is life?
Matt, you mentioned how their philosophy would be more introspective, and that gravity would shape their answer to the question, what is life? Let's dig into that. What about religion? So many of our gods reside in the heavens. What would their concept of divinity look like if up is synonymous with death?
That's a profound question. Their deities wouldn't be sky gods, but earth gods. Divinity would be found in the deep places of the world, in the stability of the rock, the heat of the geothermal vents, the crushing pressure of the deep oceans. Their entire spiritual framework would be inverted from ours. Enlightenment would be found by digging deeper, not by ascending.
From a flatter, denser, more violent planet to a race of intelligent beings forever bound to their home, this has been an incredible thought experiment. Matt, thank you for guiding us through the heavy implications of a heavier world.
It was my pleasure, David. A chilling but fascinating hypothetical.
That's all the time we have for today on What If. Join us next time as we explore another impossible scenario. Until then, stay curious and be thankful for the gentle pull of home.